Hi, my name is Derek Curtis. I work at Fowler in the Applications Department. And today we're going to be showing you the new Fowler GageMaster FT2E. It's available as new purchase on new optical comparators from the GageMaster line or as a retrofit for existing comparators that you may have in your shop already. And we're going to start our measurement routine by highlighting the circle in the center of the screen here. We have an optical edge sensor that will be working and taking the points automatically for us. So we select our circle icon, cross the edges with our optical fiber. The points are automatically registered in the software. We select finish. Our circle has been measured. I can then come over to another circle. Again, we have two circles now connected. If I want the distance between them, I simply select them and then draw the distance out. If I want a linear distance instead of a horizontal distance, I can select vertical, and that'll give me the distance between circle centers in the vertical mode or horizontal mode, depending on how I'd like to use it. I'm going to now measure an arc up here on this slot. Select circle again. Target the features on my arc. Select finish. Got my arc measured. Go down to the other end. Do the other arc. Select finish. Got our two arcs measured, and then I'll do the two lines here that are part of this slot. We've measured our slot, and now we can construct the distance between these two lines easily with our tools. The distance between these arcs, and we can get the distance to our origin. We've done some just basic inspection here, nothing too fancy, and we can easily generate a report. I'm going to create a graphic report, and I'm going to run it. And we get a full-blown repeat report with the features that we've measured and the data that we derive from those measured features. One of the big advantages to this type of product is that you can construct lots of different features from previously measured features, which would be near impossible to do on a small readout that you may already have on your optical comparator. For this example, I'm going to construct a point on the intersection of these two lines that you can see right here. So I select point in my measurement routine, and then I select the small wrench over here, which allows me to enter features to construct that point from. And as you can see, I have a point there. I say finish. I've done that point. I can do the same thing with arcs. I can select point, construction, select the two features I would like to construct that arc with, and I've generated a point at the intersection of those two. Those points can then be referenced to anything else in the measurement field that we choose. For example, I can make a point and reference it over to the center of this arc quite easily just by selecting the point itself and then the arc and dimensioning it like so. I've done some more measurements here. Let's see what our report looks like. Generate reports. In this case, we're going to run both a graphical report, which will give us this drawing dimensioned as we see it, and also tabulated dimensions, which is probably what the QC guy actually wants. And then we'll run it. And now we've got our dimensioned drawing up here. And if I select the second tab, I get my tabulated features here with all the header data that you would want to put on for your QC department to stay compatible with ISO. One of the big advantages to going to a PC-based software on an optical comparator is the ability to take the data that you can measure and construct on virtually any readout, but this one specifically. And you can export that data quite easily because we're using a true Windows 10 PC here. You can export it via the Ethernet port, USB, or you can take it and dump it into an Excel file that can actually be resident on this PC. So you have the ability to generate quite impressive reports, and those reports can be in a variety of different types. And can be saved online or offline depending on what you need for your SPC requirements. Another advantage of the FT2E Retrofit is most of the optical comparators on the market today are using an optical edge design that was designed in the 80s, and it is very old technology. It's not particularly fast. It's made primarily for accuracy using the technology that existed at the time. We have a near zero latency edge detector on here using 32-bit processors that is blazingly fast. We also have the ability to do some very elaborate mapping and error compensation on the comparator itself to tighten up even the sloppiest old comparator, so you can get great performance out of something that you may have been considering for the scrap bin. To sum up the performance features of the new FT2E on Fowler GageMaster or existing retrofit comparators, you get new improved reporting, a very easy to use graphical user interface. It'll require very little training for your staff, especially the guys that are just doing one or two measurements and then moving on. You get the ability to export your data easily and quickly. We have DXF import and best fit scan requirements, which will be brought into another video, which is more in-depth featuring. Here at Fowler, we have a working knowledge of virtually every comparator ever made, and we can retrofit this to almost everything. The FT2E is available today in both a Fowler GageMaster comparator package or as a retrofit.